Okay, so can a beginner do basic calibrations using generic PLA for their 3D printer? We'll be using this generic filament, and I would tell you the name, but I don't know what it is. I ordered some King Rune PLA and I got this. The spool is different, the box is different, there's no labeling. I don't know what I got, guys. Anyway, today we'll be following Uncle Jessy's guide on how to tune PLA settings. Uncle Jessy is a really big hitter in the 3D printing community, and this is the guide that we'll be following. However, I did add some twists to it, so I hope it helps, and please let me know in the comments if it does help you. Of course, the 3D printer that I'll be using is the Elegoo Centauri Carbon, and again, this isn't sponsored or paid for by Elegoo. As you can see, I'm using generic filaments, so it is what it is. Okay, so since we don't know what this is, we'll check out what a generic print profile can do with this kind of filament. Okay, so this right here is called a 3D printer torture test. It's basically a lot of tests smushed up into one print. And as you can see, it went through some torture of its own. But the results are still there, so we can still use it. Okay, so these are measurement tests, and they're mostly for measuring the consistency of the printer for functional prints. So today we'll actually be focusing on something more basic like the overhang test, the bridging test, and the tolerance tests. For overhangs, this actually measures how well the printer can print in different angles without supports. It goes from 10 degrees to 80 degrees, and the magic number is 45. If you can print well without supports at 45 degrees, then you're pretty good. As you can see here, for generic settings, it's actually really doing well. It went all the way up to 60 degrees. And after that, you can see the spaghetti or the spaghetti string. I don't know what you call it exactly. That's what happens when you need supports already. Now, for the bridging test, it actually measures how far your printer can print without supports. And again, the magic number is 40 to 50 millimeters. And this is 40 millimeters and this is 50. So you can see they did not do too well, but right there. But we're going to fix that. For the tolerance tests, it actually measures how much space your printer can print in between the plastic that it laid down. This is important for both functional and hobby prints. As you can see, these things right here, they have spaces, so they should be falling off, but they did not. As you can see, they're fused to the print itself, and that should not be happening. So this is a definitive fail right here. Okay, so now how do we fix all of these? You don't really need to fix the overhang, so we can focus on the bridging and the tolerance test. Okay, so this is where Uncle Jessy's guide comes in. You see, one of the most important things for 3D printing is actually the temperature. There's a sweet spot for each printer and each filament, and the best way to find that is through a temperature tower. But what makes a temperature tower so useful? Okay, so this is a temp tower. In a way, it's almost like a torture test focusing on temperature with each level with different temperatures. With this part, it's almost like an overhang test. As you can see here, this isn't that nice. And it gets better, worse. For this one, it acts like a bridging test. And as you can see here, they're all pretty good. And for this part, it's actually a cone that measures how well it doesn't string or does string. And as we can see here, I hope you can see it through my phone, but it's actually really good at 215 and at 220. I don't know how well you can see it. I hope you can see it. Since this is generic PLA, 190 to 230 should be pretty good. And if you don't know how to make a temp tower, I'm going to show you how right now. Number one, go to Orca or Elegoo Slicer. In the Prepare tab, go to Filaments and make sure to pick generic PLA. Make your way to the Calibration menu at the upper left-hand side and click Temperature Tower. As you can see here, the filament is already set to PLA, and the starting and ending temperatures are optimized for PLA. Once this is done, click OK, and it will generate a temperature tower for you. And once you have this, just click Slice Plate at the upper right-hand corner, and right beside it, if you're using a printer via Wi-Fi, just click Print. If you're using a USB, click on the drop-down arrow beside Print. Click Export G-code, then click it again once it replaces Print. You can save it in your USB and just plug it into your printer. Okay, so this is where we'll be adding the twists. See, right here. As you can see, I have 3 temperature towers right here. One is generic, one is Sunlu, and one is PLA. So basically what I want to do with all of this is to pick the best settings with the best overall results. And I chose Sunlu and Elegoo because in Amazon, they're both number 1 and 2 in PLA filaments. Okay, so now these are the results for all 3. This is the generic one, the Sunlu, and the Elegoo part. As you can see, it failed for the Elegoo part because of bad bed adhesion, but it's not the fault of the temperature test, so it should be fine. And you know what? They're all honestly pretty much the same. I hope you can see the details, the finer details here. But for the generic part, it's actually 215 to 220 that's still the best. It's the same with Sunlu right here. And it's the same with Elegoo right here. 215 to 220, they're all pretty much the same. So I guess that means that 220 and 215 are the best temperatures for this filament. Okay, so if you'll notice, even in the temperature test, there's still some stringing in the cones, even with the best temperature. And the way that Uncle Jessy fixes that is by using a retraction tower. Yeah, so basically a retraction tower is this thing. And the way that it works is by measuring how much your extruder, the thing that pushes the hot plastic through, pushes and pulls the filament inside it. However, since we already have the temperature, all that's left is to fix how much the extruder pushes and pulls. Now, how do we make a retraction test? Once again, go to your slicer of choice, make your way to the calibration menu at the upper left-hand side again, and this time, pick retraction tests. You don't need to change anything here, so just press OK. Now, it will generate the first retraction tower. Once again, just click Slice Plate at the upper right-hand corner, and right beside it, you can either print or use your USB. Don't forget to do it for the Sunlu and the Elegoo filaments. Okay, so now these are the retraction test results. They're all pretty clean actually, but if you can see it right here, the 4th notch is the best one. It's the same thing with Sunlu. First one was the generic, this one is Sunlu, and the cleanest one is the 4th notch. So it's probably going to be 0.4 for the retraction settings. Okay, so all 3 tests actually show that 0.4 millimeters is actually the retraction length that we may need. Now, in Uncle Jessy's guide, there were actually 3 steps, but the 3rd step was optional. Now, that's actually my reasoning for choosing 2 more filament settings. If we can find the best setting for this kind of filament, then maybe we don't have to go through the 3rd step. So now, let's apply these results and make our own settings. If you remember, we actually had no problem with the overhang. The main problem was the bridging and the tolerance test. Now, to show you how much that improved, I actually printed isolated tests for each. Okay, so these are the isolated tests. Right here is the isolated overhang test. As you can see, we actually got it around 65 degrees again, which is about the same as the first one, which is again, pretty good. For the bridging, now this is the real difference because we actually got it to bridge pretty well up to 60 millimeters. And if you look under, you can see the pattern. I guess we can call it 40 to 50, but if we push it to 60, it's still not that bad. Okay, so we failed miserably with the tolerance test for the generic settings, but now you can see it's actually pretty good. You can start with 0.35 millimeters. Perfectly. You can do 30 millimeters, 0.30 millimeters. 0.25 millimeters is pretty good. 0.20, 0.15, 0.1. They're all pretty good. So, okay, so now why did I do all this with some generic filament? Well, it's because converted, this is actually only $8. And now, I can't even find the online store that I bought it from. So, now, is this risky for my printer? If you want to use the ready-made profiles, I actually linked them all in the description below. Filament is kind of expensive, so I thought that this would help someone. So, if it did, have fun and peace.